Okay, let's get back to where we were. So, right. So Galileo was the only scientist at that time that took the approach of testing every theory he formulated, right? And it is very important that a theory is tested. It cannot be just speculation. It has to be tested and proven to work, right? And Galileo, you just need to be able to identify this, as I mentioned, for the diagnostic test. And the other scientist is Sir Isaac Newton. So Sir Isaac Newton is best known for his tremendous work in the law of universal gravitation. This was a breakthrough in the science community at that time in the 1600s, which states that all objects attract each other with gravitational attraction. This led to the determination of the acceleration due to gravity value of 9.8 meters per second squared. This was a breakthrough in the community because persons they had a there was a conflict of whether an object actually falls or if the earth goes up to meet the object. So it was very hot. It was a very hot debate. But Sir Isaac Newton, um, with the scientific method, proved that it was so. He also discovered Newton's three laws of motion, which form the basic principle of modern physics. As I mentioned before, Sir Isaac Newton, during his lifetime, he did a study of white light, which led to the discovery of the color spectrum. This discovery initially made him famous. So this was what made him really known as a scientist, and then his other work were identified in the community. Alright, so this won't be on your test. This is just um for just information, right? You won't be quite required to know this, but it's just for this particular presentation. Elon Musk, a very hardworking scientist. He graduated with a physics degree, and as such, he founded PayPal, which he sold, right, and invested in Tesla Motors, and he later founded SpaceX, which is a company that is at the forefront, right, head to head with NASA in studying the space. PayPal is a method you can use to pay money online, and Solar City, they install solar panels, as you can see here. These are all solar panels that don't use electricity from the grid. So they would use, if they're in Jamaica, they would use JPS, right? And these are also solar roofs. So these are just some of the things that are happening in the science community. Let's move on. I just had to show you have scientists working currently in our time, right? It's not just, you have a lot more to physics. It's not just old formulas, right? Physics is a very relevant field. All right, so now we'll move on to the second aspect, lab equipment. All right, you'll only be required to know these and to basically know what they do. You might have seen some of them in last year, right? Some of them might look familiar. So the most used physics lab equipment include meter rule, that of course measures the distance, stopwatch, of course time. I tried to find the simplest ones. I tried to give you the simplest ones I could find. Clamp stand, and the most used one. Clamp stand is used to hold items mounted. You've probably seen that before, and you'll be using that in possibly 60% of your labs coming this year. You have the top pan balance that is used to measure small masses, just small masses. Thermometer is used, of course, to measure temperature. Bunsen burner used as heat source. Beaker to store liquids. Vernier caliper is used to measure small distances, very small distances. And the ammeter is used to measure current. Voltmeter is, of course, used to measure voltage. Okay, important lab rules. The most important critical lab rule is to follow my instructions, or to follow the instructions of your lab technician. Why? Because they know the nature of the lab, they know what is required of the lab, so you have to pay keen attention when carrying out a lab. It is very imperative that you pay close attention to the lab, right? No eating or drinking in the lab. That's a given. No experiment should be conducted without safety gear. So your lab coat is a must. If you're dealing with any other substance that could cause damage, you'll be using like simple apparatus. So it won't be a danger to your body, really, right? You won't be in danger with the apparatus that you'll be using in physics, mostly like springs. um you can see you won't be using any chemicals, really. So you'll only be required to wear a lab coat. And if there's a case where you need goggles to protect your eyes, it will be provided. All right, no form of horseplay will be tolerated. You're big senior students, right? You're moving into the senior aspect of the school, so I expect nothing less. I don't expect any plane. That will not happen, because right, that to it will lead to some strict actions being taken out. All right, so ensure that all gas outlets are off when not in use. That is if, of course, we're using the Bunsen burner. If we're using a Bunsen burner, please ensure that the gas outlets are off. You will know when you begin to do labs. You will be aware of the actual gas outlets. Right? Okay. So the lab format, you should have been acquainted with this already. This is just a general lab format. What is expected. Uh, so you may be asked to place them in correct order, right? So it's just good if you can memorize them or know where they go. So you have your date, topic, your aim, your materials or apparatus, your method, your results, your calculations, if there are any calculations, your precautions, your source of error, your limitations, and your conclusion. Alright, let's go through them. This is the date of the lab. This is very important. When you're doing a lab, you should make note of the date. Alright, great. And students, your topic will be given, aim will be given, materials and apparatus will be given. And we are coming with a new way of approaching things, where you will be provided with the method, right? What is the most important for a lab is the results and the calculations, precautions, and the source of errors, limitations, and conclusion. Results would include your tables and your graph. Calculations you will know if we have any calculations for that specific lab. The precautions are essentially the measures that you took to ensure that the lab went well. For example, if you're doing a lab that can be affected by the wind, if they realize that the wind is affecting your lab, what you could do, a precaution that you took was closing the windows, right? Um, and of course, you will know based on the method what precautions you took. Sources of error. These are some simple things that could have caused error. We'll discuss them um, further down in the course. Some of the possible sources of error, right? It could be your mistake, or um, you know, it could be your mistake, or you made a mistake, or you saw on the graph where you you got a wrong value based on the graph. So you won't be required to necessarily define these. You just need to be aware of them and know what is required. And limitations are things that you cannot really control. Um, Limitations, things that could impact the result of your lab or experiment that you cannot really control. You have no control over it. And your conclusion is based on your aim. So you'll go back to your aim. If your aim was to determine the height of a chair, your conclusion will be that the height of the chair is so and so, right? So I need to see the conclusion coming out from the aim. Right. All right. So we'll just do this and then we'll stop here for now. The area and volume, just an introduction to this. We'll go over this again the next time we meet. So area is defined as the amount of space that is occupied by a 2D shape, a two-dimensional shape on a flat surface, such as a square, a circle, or a triangle, right? And area is measured in meters per second. Alright, volume is defined as the amount of space that is occupied by a 3D shape. For example, a cube, right? A cube, or a sphere, something that can take up a space. So comparing to a 2D object, 2D object would be like a flat piece of paper, while a 3D object, of course, would be like a box. So the volume is basically the amount of space that box takes up in a three-dimensional. Alright, so this basically determines the amount of water that the actual object can hold, right? The 3D object, the volume determines the amount of. So when we ask the volume of an item, it's essentially the amount of water that it can possibly hold, right? And volume is of course measured in meter cube, right? And we'll stop here for today. Next time we will go through the different the how to calculate the area of a regular shape. That's what we'll cover next in our next class. Alright, and we will estimate the area of a regular shape. We'll try and cover this. We have 2 sessions really. So we covered most of this, so we only have this area left. and it should be relatively easy. Right? All right. Have a nice day.